Hello and welcome back to my channel. In this video, we're going to talk about system version temporal tables, keeping a full history of data changes, allowing easy point-in-time analysis. My name is Wally Pons. I'm a SQL Server DBA with over 25 years of experience in Microsoft SQL Server and other types of RDBMS. You may contact me in one or more ways as shown below. I'm also the founder of Data Group of PVSoft since 2013, instructor, writer, and IT consultant since the late 90s with a growing customer base. What is a system version temporal table? A system version temporal table is a table configured to automatically track and store the full history of data changes over time. SQL Server manages two tables. One is the current table, and the second one is the history table. The current table, also known as main table, contains only the most recent version of each row. The history table stores previous versions of rows every time an update or delete occurs. SQL Server inserts records automatically without triggers. This feature allows you to query the data as it was at any point in time, making it extremely useful for auditing, reporting, recovery from accidental changes, and analytics. Let's take a quick look at the table below right here. One of the main features that you find on system version temporal tables is called for system time. For system time is an option you use in queries where you can go back in time and do a data as of from two or old versions based on one specific date or specific dates. As you can see on the screen, we have the script to create our main table and history table as well. The things we need to take into account to do this. One is adding two columns, one for the start time and the other one for the end time. They should be type datetime 2, and the start time should be with this option, generated always as row start hidden and not null. Similar thing applies for the end time column, generated always as row end hidden and not null. We need to set up period for system underscore time where we specify the names of the columns we're going to use. Also, we need to turn on system versioning, as you can see right here, and specify the name of the history table. In this case, the name is going to be table customers history. And it has to be on the same schema as the source table or main table. We're going to set up as well data consistency check. We're going to set that to on. And history retention period, we're going to set it to 1 year. We could potentially set this to another value depending on your needs. Here's a list of the values that we can use. We could use infinite, we could use day or days, week or weeks, and so on. Okay? So let's proceed and create our table. Let's proceed and click on execute so we can create both tables. And they created. Now, let's take a quick look at the sys.tables system table in SQL. That table shows me how many tables I have and the description and all that. I'm going to just use some of the columns from that table. Okay. Let's zoom in a little bit to the results. And there it is. I got two tables. One is called table customers and the other one's called table customers history. For table customers, I have my retention period and I can see it's 1 year, and I also can see my history table ID, which I can relate to the object ID for the table customers history, as you can see right here. The reason I'm showing you this is that for some reason the history table might be created with this similar name to the main table. That might happen as well. And one way to locate it is by using the history table ID and comparing it to the object ID. That way you can find it really quick in case it has this similar name. It's hard to find. Now we're going to test our history table. We're going to do some inserts, updates, deletes, and see the information that we collect on table customers history. But before we do that, I want to show you something because this is a brand new table. Okay, this works pretty fine for a brand new table with no data. What if you want to implement this into your existing table, which makes a lot of sense. You already have a table with some data, but you want to keep your track of updates, deletes, and all of that information. You can do that as well. So we're going to simulate that we have an existing table and we're going to modify the table to add system versioning on that one. So let me paste this query right here and I can explain better. I'm going to create this table. It's called table products. So you can see it has some columns, not too many columns for a product table. Let's create it and let's take a look at the table existence. We're gonna run the same query we ran before for system tables, and there it is. As you can see, we already have table called table products. It has no history table ID, so it's a normal table. No big changes here. We need to do two alters. So the way we do this is the first alter is to add the two columns, the start time and the end time. The only difference between the script we use to create a table and this one is that since we're going to use it on an existing table with existing data, and these two columns do not accept not null values, we need to add a default value. So you can see here, we have a default of 1900 or 101 for the start and 999 December 31st for the end time. Okay. Okay. So we need to do the alter and add these two columns. The columns will be added at the end of the table. Okay. That's one step. Now, the next step is enabling the system underscore version. We're going to do something similar. We're going to enable system versioning. We're going to have a history table. The history table is going to be called table products history, as you can see right here. It's going to be in the same schema. We're going to turn on data consistency check. And we're also going to enable history retention period for 1 year. It could be a different value, but we're going to use 1 year for the default. Okay. We can run this. And we're going to go back to sys.tables and see what we get. Let's zoom in a little bit. And there it is. As you can see, we have our information for table products. Now, table products, it's already enabled for retention. It has a 1 year retention and it has a history table ID, which is the same as the object ID for table products history. That way, you know the relation between one and the other. Now let's proceed and test our table customers with some updates, deletes, inserts, and see how we can retrieve that information. Okay, let's insert some data into table customers. To do that, we're gonna put some fake data. Okay. These are not real people, I just made them up. Put 5 rows into the table, and we got 5 rows. Now let's do a select on both tables, table customers and table customers history. Okay, so let's see what we get. And as you can see, table customers has 5 rows right here, and table customers history, it's totally empty. If we run this other query that uses for system all, and this one uses for system all with a condition for customer ID 1, let's see what we get back. So far, if we do this one, we'll get all the inserts that we have done on this table, actually the initial inserts that we did. Also, we get the information for customer ID 1 using the where clause. Let's do an update and see what happens. If we do an update, in this case, we're going to do an update for customer ID 1. We're going to change cost category. We're going to change that from 0 to 1. Let's execute that. Let's take a quick look at table customers and table customer history. Okay. So customer ID 1 has customer category set to 1, but it used to be 0. We also can see the start time and the end time column, so we can have a relation of validity when that happened. If we run the same information for the for system all using a where clause, we're going to be able to see the previous value and the new value, which is an advantage for this type of processes. Now let's do a delete, and we're going to delete customer ID number 1. Okay, let's run that. And if we take a look at table customers, customer ID 1 is already gone. But if we go back to table customers history, we can see the information for customer ID 1, where it used to be customer category 0, then it became customer category 1, and now it's gone. For the for system time all, we can see similar information as well. And for system time all as well, without the where clause. As you can see, we can see both informations for customer ID 1. If we want to do a truncate, I'm sorry to tell you, you're not able to do truncates on table. Won't allow you to do that, but you can do a delete from without the where clause, which will basically do the same purpose. And it's done. We go back to table customers, it's totally empty. If we do a select on table customers history, we can see all of the information that was deleted, even the updates that were done. So in a way, we can go back in time and recover that information. If for some reason you need to drop any of the tables, either the main table or the history table, the first thing you need to do is turn off system versioning for the main table, in this case, table customers. If you try to drop any of the tables, either history or the main table, it will give an error message. None of the tables can be dropped unless you turn that system versioning off. So there are instances in which you may want to do this. Let's say you don't want to have the history table anymore. If you don't, then you have to disable that by turning it off. Let's do that now. And since we just did, we can go and drop the history table. And it's done. Also, now you're able to drop the customers table. Let's drop that, and it's gone. All we got left now are the products and product history table. Those are unaffected for the moment. And this will finalize the video. Would you like to hire me for your SQL questions and solutions? You can reach me at Fiverr or at Upwork. To download a copy of the script used in this and other videos, please visit my GitHub repository. Please like and subscribe. You can also leave a comment or message if you wish to do so. Thank you for watching.